Okay, so now that we have a good handle on molar ratios, it is time to do stoichiometry. So, stoichiometry is calculating masses and reactants of reactants and products. Okay, you might do based on how much reactant is used, how much of the other reactant do we use? Or you could do based on how much reactant is used, how much of one of the products is made. Or you could even do based on how much product is made, how much reactant did there have to be. Okay, but regardless of what you're doing, you first always have to balance your reaction. Okay, if you don't use a balanced equation, you will not get it right, because then you won't have the right molar ratios. Okay, second step, and most of the time this will be required, but you need to convert your mass to moles. Okay, we can't use a molar ratio with mass. It has to be from the mole point. Then you can set up your molar ratios. Okay, so that's what we've been doing for the past couple of days with the dimensional analysis. Okay, once you have your mole ratio set up, you'll use it to actually calculate the moles of whatever thing we are asking about. Could be the other reactant, could be a product. Okay, and then finally, you'll need to convert your moles to mass. All right, now these two steps, 3 and 4, look like one step when you do the math, okay? But if you set up your molar ratio correctly, the rest of this is pretty easy. You've already been doing it, okay? The tricky thing is just putting it all together. So let's work a stoichiometry problem. 6.50 grams of aluminum reacts with an excess of oxygen. How many grams of aluminum oxide are formed? Okay, so we know we have 6.5 grams of aluminum, and we want to know about aluminum oxide. What's the first thing we have to do? Hopefully you are saying that you need to write your balanced equation. So, start out with our arrow. What are the reactants in this case? Okay, reactants should be aluminum reacts with excess oxygen. So, aluminum plus oxygen. What are the products? Aluminum oxide. Aluminum is 3 plus. Oxygen is 2 minus. So you need Al2O3. All right, and then once you know what your reaction is going to be like, you have to balance it. Okay, so we have, let's see, a 3 and 2 as far as oxygen goes. So we know we're going to need a 3 here, a 2 there, and a 4 in front of aluminum. So now that we have our balanced reaction, we need to move on to the math. What's the first thing we have to do? Hopefully you were saying we need to convert to grams. 6.50 grams aluminum. This is something right here, this grams aluminum, and being really clear and explicit with your units is something I am actually going to test you on. You have to do it to get all of your points on your tests and quizzes, okay? Because this is vital to not making mistakes. So our first step is going to be the 6.50 grams of aluminum. We're going to convert that to moles, which means we need our molar mass on the bottom, the 26.98 grams of aluminum to 1 mole of aluminum. Okay, next thing is to set up our molar ratio. So I know I want moles of aluminum on the bottom, and then if you remember, I was curious, or I wanted to know about how many grams of aluminum oxide, so moles of Al2O3 are going to go up top. What I plug in is, I know my number for aluminum is 4. I know my number for aluminum oxide is 2. Okay. And last thing, I have to convert now my moles of aluminum oxide to grams. So 1 mole Al2O3 to cancel out moles and 101.96 grams Al2O3 to do my final step. Okay? I know I have set this up right if I can go through and cancel out all of the units and the compounds and end with grams of aluminum oxide. If I did it right, then that'll happen. If I did it wrong, then I'm going to get something else. Okay, so grams of aluminum, moles of aluminum, moles of aluminum, moles of aluminum oxide, moles of aluminum oxide. My end is grams of aluminum oxide. Okay? All right. So now that we actually have it all written out nice and neat, let's talk about what we're actually doing math-wise. You're going to do 6.50 times 1, which doesn't really do anything, times 2 times 101.96, and then we're going to divide by 26.98 and divide by 4. And when you plug that into the calculator, you get this. And then the only thing left is to address sig figs. We started out with 6.50, which is 3 sig figs. So in all reality, your best answer here is 12.3 grams of aluminum oxide. Okay? So what I want you to do is see if you can get this one set up. It's a pretty simple equation to write out, as long as you remember that hydrogen and oxygen are diatomic. And then, so pause the video, try it, see if you get the right answer, turn the video back on and watch me do it. Alright, so again, first thing we need to do is set up our equation. So we react hydrogen plus oxygen to make water. I have to double this to account for my oxygens, which makes me double the hydrogen. Okay. Then I need to set up my stoichiometry, which is my 3 steps of dimensional analysis. 12.25 grams of hydrogen. The molar mass of hydrogen is 2.016 grams. That's going to be equal to 1 mole of hydrogen. My molar ratio step, I'm going to put 2 moles of hydrogen, because that's the ratio number. And I want to go to water, so that's going to be 2 moles of water. And finally, I need to convert my water back to mass. 1 mole of water is 18.016 grams of water. And I can double check to make sure I have this set up right, if all of my units and other compounds cancel out, giving me grams of water. So we have grams of hydrogen canceling, moles of hydrogen canceling, moles of water canceling, and my final units are grams of water. So I should have this set up correctly. Okay, so again, I'm going to do 12.25 times 2 times 18.016. Then I'm going to divide by 2.016 and divide by 2. That gives me 109.47. Then the last thing to account for is sig figs, so my final answer is 109.5 grams water. Okay, so make sure you have notes for class and complete the online assignment, and I will see you in class.